question like this in your exam, how are you going to approach it? The question says, if 4,000 columns of electricity are required to discharge 0.5 mole of potassium from a molten potassium chloride, then the number of coulombs required to discharge 3 moles of lead from molten lead 2 bromide is. The question you're going to ask yourself first is, what is the relationship between potassium and lead? Totally different, right? So why are we asked to look for the coulombs required to discharge molten lead to bromide when the first sentence was talking about potassium? Now, this is where we talk about the second law of electrolysis. When you see a question like this, that has to do with quantity of electricity discharged. And of course, when you see the word discharge a whole lot of times, you should know that it has to do with electrolysis. Now, when you see a question like this and you're having the first electrolyte and you're having a different electrolyte, always remember second law of electrolysis. And second law of electrolysis states that if the same quantity of electricity is passed through two different electrolytes, the number of mole is going to be inversely proportional to the charge on the element that has been discharged. I'm going to explain. Now, the number of mole is going to be inversely proportional to the charge. So let's take, for example, potassium. Potassium was discharged from potassium chloride. So we have that this was discharged. Now, remember in electrolysis, the electrolyte will be dissociated and discharged into different ions. If you're having issues trying to understand electrolysis, the whole concept of electrolysis, I have a video on my YouTube channel where I explain extensively on electrolysis. So I'm going to advise you to go check it out. You can click on the link on my bio to be directed to the video. Now, back to this. So we have that number of mole is inversely proportional to the charge on the element that is being discharged. So, for example, if this is potassium chloride, the charge on the element discharged here, which is potassium, is +1. So we're going to use V to represent that. V here is going to represent valency. Now Q here would be our constant. Q here represents quantity of electricity. So if we remove this proportionality sign, I'm going to have N equal to Q over V. Now, guys, remember this formula for electrolysis that says that mass over molar mass equals to quantity of electricity times NF, where N is valency of the element. This is because quantity of electricity can be represented in two ways. It can be represented with IT, which is called quantity of electricity equal to current times time. It can also be represented with Faraday. So this is also quantity of electricity. And the quantity of electricity we're talking about when we have two or when we're comparing to electrolytes is this quantity of electrolysis, F. So guys, we're going to make F the subject of formula. Come here. Remember that M over M is number of mole, because number of mole is mass over molar mass. So we have that number of mole is equal to this quantity of electricity all over this quantity of electricity. Now, where this represents valency. All right, so we're going to bring this, import this here. So we're still going to have our N here. We're going to call it V, and then we have Faraday. Like we said, this is the quantity of electricity that is being passed. That is the same. Now we're going to make F the subject of formula. You're going to have that NVF is equal to Q, quantity of electricity. For F to be on its own, you divide both sides by NV. All right, so F is equal to Q over NV. I'm just going to clean up all of this. Now, this is the real gist. Quantity of electricity is equal to Q over N, which represents number of mole, V. So when you see a question like this in your exam, please, you're not going to be doing all of those things I just did. I was just trying to explain to you the concept of comparing to quantity of electricity for two electrolytes. Now, when you see a question like this, don't go through all that. Just remember the second law of electrolysis and remember this formula that Faraday is equal to Q over number of mole times valency. V represents valency. Now, when we have two electrolytes and we're looking for the quantity of electrolysis for one of the electrolytes, it means that we have quantity of electricity for what is discharged here, potassium. So this is quantity of electricity for potassium. And I have another quantity of electricity for lead. So this is it. So Q for potassium equal to Q for lead. Now, what was given here? If 24,000 columns of electricity, so for your potassium, you have 24,000, right? So we're going to have 24,000 here. What is the number of mole of potassium here? You've been given in the question 0.25. So I have 0.25 here. What is the valency of potassium? Now, when molten potassium is dissociated, you're going to have it separate into potassium and chlorine. Please, this is different from aqueous form. And for you to understand this better, I explained the whole concept in my video on electrolysis. So you have potassium, you have chlorine. If you dissociate this, you're going to have potassium univalent and chlorine univalent. So the valency of potassium here is +1. So over here, valency is going to be 1. Quantity of electricity for lead was not given, and we were asked to look for it. The number of what? Coulombs. Remember that quantity of electricity is measured in coulombs. All right, so quantity of electricity for lead is not given. That's what we're looking for. Now, if lead to bromide, this is what lead to bromide is. If this is dissociated, we're going to have that the lead and what? The bromine. So lead is divalent and bromine is univalent. So this is what is being discharged. So my valency here is going to be 2. So quantity of electricity for lead is just there. The number of mole was given as 3 moles. So we have times. So what is the valency of lead here? We have it as 2. So when you see questions that has to do with second law or Faraday's second law, don't forget the formula Q over NV equal to Q over NV. So this is electrolyte A, electrolyte B. Okay, so let's make the quantity of electricity of lead subject of formula. You have Q PB is equal to 24,000 times 3 times 2 divided by 0.25. 24,000 times 3 times 2 divided by 0.25. So let's see what we're going to get. So we have this as 576,000. All right. So come back to the options. I'm going to choose B. This is my answer. So if you're going to be solving questions on Faraday's second law, remember that Faraday is equal to quantity of electricity over number of mole times valency.